delivering quality education, expanding access to learning, serving learners' learning needs, tackling challenges of the present time, supporting every learner's dream, reaching young Tagumenians where they are today. From the music capital of the Philippines, advancing in the challenge of distance learning. Bringing you quality education straight to your home. Plug yourself in. This is DepEd TV. Tara na!
And I'm glad that you will be with me today. It's time for a new and digital way of learning in the world of mathematics. The most essential competency that will be discussed in this video is generating patterns. This is Mathematics Grade 10, Module 1 of Quarter 1. At the end of this video lesson, you are expected to generate patterns. Please make sure that you have reviewed your pen and the paper, okay? Let's go! Let us learn while having fun. Indeed, expect a meaningful learning. Learn plus fun equals meaningful learning. Before we start our lesson for today, can you guess what are the next shapes for this item? Try to recognize the pattern and its characteristics. Here's number 1. What have you noticed? First, all shapes are polygons. These are squares and triangles. Second, the number of square is constant 1, while the number of triangle is increasing by 1. Looking at how the figures are arranged, what do you think will be the next figures? The answer is 4 triangles. Then what about this one? What do you think is the next number? The correct answer for this item is 30. Why 30? Because each term is obtained by adding 5 to each preceding term. Yay! You got it right. Let's have another one. What do you think is the next number? I will give you 5 seconds to answer. The correct answer is 32. Why 32? Because each term is obtained by multiplying 2 to its preceding term. That is, 1 times 2 equals 2. 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. And 16 times 2 equals 32. So the answer is 32. Now, observe these given items. Does each item form a sequence? Yes, it does. Good job, guys. What is a sequence? A sequence is a function whose domain is the set of positive integers. It also means an ordered list of numbers where the numbers are called terms and are often written as a sub 1, a sub 2, a sub 3, a sub 4, and so on and so forth till a sub n. A sequence can be finite and infinite. When do we say it is finite? A sequence is finite if its domain is the set of positive integers such as 1, 2, 3, 4, 5, and so forth till n for some positive integer n. While a sequence is infinite if its domain is the set of positive integers 1, 2, 3, 4, and so on and so forth where ellipsis dots. It has ellipsis dots, which indicate that the sequence goes infinitely. Which of these are finite sequences? And which are infinite? Let us find out. Does each sequence have first and last term? Yes, it has. For these sequences, 1 and 1/2 are the first term. And the last terms are 11 and 1/6. Therefore, these are finite sequences. What about this? Does each sequence have first and last term? Oops, it has only first term and no last term, only ellipsis dots. Therefore, these are infinite sequences. Can you find out the next three terms of these sequences? The next three terms are 1/6, 1/7, and 1/8. What pattern is shown? Well then, the denominator increases by 1 consecutively. How about this one? The next three terms are -5, -7, and -9. What pattern is shown? Excellent! Add -2 to the previous term to get the next term. Let us level up your learning. Can you find out the first three terms of these sequences? Defined by each general term or nth term. Say for example, number 1. A sub n equals 3n minus 2. How to find the first three terms of this sequence? Just simply substitute the value of n by 1, 2, and 3. First thing to do is to make table of values. And a sub n equals 3n minus 2. If n equals 1, we will have 3 times 1 equals 3. That is, 3 minus 2 equals 1. So first term is 1. What about n equals 2? We have 3 times 2 equals 6. So 6 minus 2 equals 4. So a sub 2 is 4. What about if n equals 3? We will get 3 times 3 equals 9 and 9 minus 2 equals 7. Hence, a sub 3 equals 7. Table complete. Yes. Therefore, the first three terms are 1, 4, and 7. For this equation, a sub n equals 3n minus 2. The same process for this equation. A sub n equals n squared plus 3. So if n equals 1, that is 1 squared or 1 times 1 or multiply 1 by itself. And that is equal to 1. So the sum of 1 and 3 equals 4. So a sub 1 is 4. What about n equals 2? We will get 2 squared or 2 times 2 equals 4. 4 plus 3 equals 7. So second term is 7. Finally, if n equals 3, that is 3 squared or 3 times 3 is 9. 9 plus 3 equals 12. Therefore, a sub 3 equals 12. So the first three terms of the sequence are 4, 7, and 12. Yes, your answer is correct. Very good. Did you find the discussion helpful? To check your level of understanding towards the lesson, find the first three terms of the following sequences given the nth term. I will give you time limit to answer each item. Are you ready? Let's start. Good luck. Number 1. A sub n equals n plus 4. This will be answered for 10 seconds. Time is up. Here's number 2. A sub n equals 2n minus 5. This will be answered for 30 seconds. Third number. A sub n equals 3 to the power of n. This will be answered for 20 seconds. Time is up. Now, are you ready to know the correct answers? I know you are excited. Remember to be honest in checking, because it is not the score that counts, but the learning you gain that matters most. The correct answer for number 1 is 5, 6, and 7. Why 5, 6, and 7? Because if n equals 1, that is 1 plus 4 equals 5. So a sub 1 equals 5. If n equals 2, we will get 2 plus 4 equals 6. So a sub 2 equals 6. Finally, if n equals 3, this becomes 3 plus 4 equals 7. Hence, a sub 3 is 7. So, the first three terms of a sub n equals n plus 4 are 5, 6, and 7. Yeah! You got it right! Congratulations! How about problem number 2? The first three terms for problem number 2 are negative 3, negative 1, and 1. How to get negative 3, negative 1, and 1? Given the equation, a sub n equals 2n minus 5. If n equals 1, that is 2 times 1 equals 2, then 2 minus 5 equals negative 3. So a sub 1 is negative 3. How about if n equals 2? You will get 2 times 2 equals 4, then 4 minus 5 equals negative 1. So a sub 2 is negative 1. Finally, if n equals 3, you will get 2 times 3 equals 6, then 6 minus 5 equals 1. Hence, a sub 3 equals 1. So, the first three terms of a sub n equals 2n minus 5 are negative 3, negative 1, and 1. Wow! You got it right! Congratulations! Let's have the third problem. A sub n equals 3 to the power of n. The first three terms are 3, 9, and 27. Why 3, 9, and 27? So a sub 1 is 3. If n equals 2, this becomes 3 squared, or 3 times 3 is 9. So a sub 2 is 9. If n equals 3, you will get 3 to the power of 3. That is 3 times 3 times 3, and that is 27. So a sub 3 is 27. Therefore, the first three terms of a sub n equals 3 to the power of n are 3, 9, and 27. Are all your answers correct? Wow! Fantastic! Congratulations! Deserve a round of applause for demonstrating skills in generating patterns of a sequence. That's end our video lesson on generating patterns. I hope you enjoyed our discussion today. Let's keep learning math with fun and excitement. See you on our next episode on sequence. Bye-bye, keep safe, and God bless everyone.